So in this presentation, we are going to give an update about the status on web in AGL. I will try to be brief as we are a bit behind the schedule. So the plan for today is like doing a high level recap on the goals we have for supporting web on AGL, and then introduce the status of the web application manager one in the platform, what we have been working on, and which are the plans for the future. So the main motivations we that were in mind when we started to work on providing a web runtime for AGL was like giving full web platform support. So making HTML first class citizens on AGL. So this was enabling the capacity to run any kind of front end framework in AGL. So running web applications using all the capabilities that are provided out of the box by supporting web standards and web APIs available in the platform. And this was already allowing us, we were doing a presentation about this in past ALS, that could allow to run several examples of web applications, even bundled Flutter applications that were already possible to run them into AGL, as we were showing in that presentation. So yeah, any case of HTML technology running there. So also the idea was supporting native-like experience on web applications, so you can integrate seamlessly in the system available APIs. We will explain that we have ongoing work related with the changes on the application framework to gradually enable back this functionality. Also integration with vehicle to cloud services. And yeah, in the end, it's like having the capacity to reach like a wider set of developers for making their applications and services available into AGL. The development tools are already available and are well known, have been used for ages. So any existing web technology or framework can be run directly into AGL. And yep, it can be interoperated with any other front-end and back-end services. So that's what the status and of the main goals have been, and we are making that, enabling them in AGL. So I will hand over to Jose so he can follow
Oh,
from.
okay. So the centerpiece for this web strategy for AGL is WAM. WAM is an acronym. It's the name of the component, and it means Web Application Manager. So next. WAM has been used for close to 10 years as the centerpiece of AG Electronics WebOS that is being deployed on TV products, but also on a wide range of other devices. And this component has been open source as part of the WebOS open source edition like a few years ago. So it's a public component, it's upstream, it's available, and development is active nowadays because it's a part of what is used for the LG products, and there's this intention to keep it open for the time to come. Okay, next. Okay, so first thing is that WAM is built on top of Google Chromium. It's a fork of it where it is trying to upgrade continuously, where it is trying to keep a manageable delta with the upstream product. And the idea right now in WAM is using as much as possible of the upstream components and the upstream technologies offering in Chromium. So as an example, the Wayland support is done with the upstream Ocean Wayland backend. Ocean is the abstraction for platform integration in Chromium. This has been developed last years as a shared project between Google and Igalia. Yeah, it's nowadays when you use Chrome in Linux, it's already using this as the backend for X11, and very soon it will be using Wayland too. Okay, so the technology is the same as regular Chromium. So it's an architecture that shows the state of the art of the GPU acceleration with delegation, with security, with all the pieces you want to have in a modern web browser. The solution has been tested in a wide range of embedded devices, different boards, different architectures, Intel, ARM, different GPUs. So it's something that comes with some history. That means that many cases are already supported, and the integration time for new hardware is usually low. Well, as a web component, as a web browser, it has support for the cloud native technologies, and specifically for anything that you can do from a front end, a web front end point of view. Next. Okay, so what does one provide? It provides an architecture that is very similar to a browser. So you have resources shared among all the web applications to make it efficient to launch applications, to have lots of memory savings because of not needing to raise up different web runtime for each of the applications. So yeah, it's quite efficient, and that's one of the biggest wins. There's control of the life cycle of the application. So applications will be launched, will be closed when memory is needed. It can recover context of them. So usually you get something similar to what you get on a tab on a web browser, but with standalone web applications that are having their own security context. So yeah, the idea is also having some security between among the applications, and that the way they interact together is the same as we expect in a web browser, where we have the security origins contexts. The last point is that it's extensible. This has proved useful for several platforms, but the idea is that when the web platform is not enough for integrating your platform, there are several points of extension that allow to add new native integration using JavaScript injections. You can also integrate in the browser process side, so you can do the system integration, the system APC, the system protocols at different levels. Next. Okay, so about the status, this is a brief of the work done so far this year. The main work has been around two directions. One is Aggrade as usual. Aggrade, we moved to the version 87 of Chromium. And we already revised and are working with the Qt-less version of WAM. WAM was using Qt in the past, but not anymore. And we are using now one that is not requiring Qt anymore. So that's something that reduces dependency for the future. We've been also working on the integration with the new application framework that basically the old one was removed. So we need to integrate again with the new services, the AGL compositor and the app launch D that was presented by Daniel a few minutes ago. Yeah, we are moving to make the applications work on top of the new framework. An additional work was doing several experiments with Flutter running on top of WAM. That's an interesting use case because on one side, we obviously prefer Flutter applications to run natively. But for the cases we don't want to do it, maybe because we want to have the web distribution channel for applications, or we want to have a multi environment application that is running on the device, but it is also running in the user mobile phone or things like that, then Flutter opens several doors for this kind of integration. So having it running inside WAM is also a good, interesting case. Next. This is about the ongoing work. So after these refactorings for application framework, we are doing stabilization and bug fixing, making things work smooth, work on the reference hardware. Then we are expecting to move towards the new IPC that is agreed eventually on application framework. And yeah, we are continuing with the web applications port to the new APIs as they are done. And the last one, but it is going to happen early actually in the plans, is upgrading to Chromium 91. That is the latest one provided by WebOS open source edition. Next. And this is more or less the plans for what we want to do this year, mostly. First, obviously, is maintenance. So we want to do performance improvement, but also bug fixing. We want to make one as reliable as possible. And then the second part is continue the upgrades as they are shipped out by WebOS open source edition. We want to have this Chromium 91 upgrade soon, and then we will have grades very likely for some 90 something in Q3 and maybe 100 something in Q4. Yeah, we need to continue with the application for framework adaptation. I think that the key here is what happens with IPC, because right now we have the basic integration with the system, with being able to launch applications, but we will need to talk to the system services to be able to access system settings, to the canvas for getting the canvas replacement, to get the information about the car status, navigation information, things like that, that we want to communicate with. So once we have an agreement to IPC and we have a proof of concept working with that, we'll also adapt web application manager, reference web applications to use that. Okay, next. Okay, this is a couple of notes about other not so priority targets. One is the idea that we want to have one running both in the Flutter and the Qt applications. It's going to be very likely optional thing, basically because building one has a cost in build time. We don't want to make things harder for other component developers. So the idea will be that you can build the Qt or the Flutter demo with the web support provided by WAM, and that would be an option. And then some ideas that have lower priority that will likely span in further years in the future. One is creating a web application SDK, so it's a part of the platform. So people, when they develop web applications for AGL, those are working on all the downstreams using AGL. And then, well, the application store and installation services, that is something that would be nice, but we are not hiring on this because it's usually something that each of the vendors want to have their own thing. So if we capture interest in getting a unified application store installation service in AGL, then that's something that we'll be interested on because of the nature of web applications. That could be as a way to provide third-party developers with a channel to ship applications in AGL. So that's it. If there's any question, we can go with there, but otherwise, these are the conclusions of what we talked about today. So, okay, so thank you.